On your screens right now is a very challenging geometry question. This question is something that very few test takers get correct. If you want to challenge yourself, pause the video and give this a shot. Okay, now if you tried, you know why this is hard. I'll actually show you what percentage of people mark with choice to show how much confusion there is. As you can see here, E is the correct answer and only 22% of test takers get this correct. This is a super low accuracy. And not just that, look at all of the other choices. There is a good percentage of votes that went to each of these choices. What does all of this indicate? Well, for one, yes, it proves how hard the question is, and since every choice got votes, it indicates how confused students are about this question. All of this confusion, why is this happening? Why do you think so many people are going wrong with this question? Well, the primary reason is not the gap of any conceptual understanding. It's not that they don't have the right conceptual knowledge. Despite knowing the concepts, the biggest reason that students go wrong in this question is the lack of ability to use one powerful process skill that can turn any super hard geometry question into a straightforward one. Hi, I'm Shweta. I'm the lead Quant SME at e-GMAT, and in this video, my goal is to acquaint you with that power process skill of visualize. So by the end of the video, we will have solved this hard question in a step-by-step manner so that you will be comfortable with the process skill by the end. You will know what is the right way to apply it, and then you will be ready to take on more challenges like this. And to give you your first challenge, I will give you a practice question at the end of the video. So stay tuned. Alright, let's start solving this. Now, when you read this question, let's understand every part. In the xy plane, region R consists of all points x, y such that 2x plus 3y is less than equal to 6. Okay, so I'm talking about all x, y points that will satisfy this inequality. Then is the point R, S in region R. If I don't think about plotting this, don't think about visualizing what this means, and if I stay only in algebra, then this is all that I am given, and what is asked is whether R, S also lies in this region. For it to lie in the region, by definition, it has to satisfy this inequality, right? So my question really is 2R plus 3S less than equal to 6? Now just see the given inequality and this inequality that we need to check, they're just so similar. All that has happened is in place of x, it's now R, in place of y, it's now S. So when you stay in algebra, you can't really see what's happening. What does it mean for this thing to work? And then when you get into statements, there's more of algebra. You look at the first equation, 3R plus 2S equal to 6. Now till now you had inequalities and now you have an equation. Again, what do I do with this? There are going to be infinite points that will satisfy this, right? It's a linear equation in two variables. Out of these infinite points, how will I make sure whether this sum is less than equal to 6? It's not even the same thing. You see, this is 3R, this is 2R, this is 2S, this is 3S. If it was directly 2R plus 3S equal to 6, I would have said yes, because we just wanted, is it less than equal to 6? And somebody told us it's equal, so it would have been a yes. But no, it's not that easy. Here the coefficients are reversed. Now, then when you go to statement 2, it's more inequalities about just R and S. Again, it could be infinite possibilities. If R is less than equal to 3, there are infinite values it can take, right? Similarly for S. Now, how far will you go and check for which ones this is working, which ones this is not? This little discussion was to show you that sometimes when we bring a lot of algebra into geometry, we complicate our work. We get tangled into complicated calculations that end up taking a lot of our precious time. We know we are in a timed environment when we're doing the exam. So it's not just about getting correct answers, it's about being efficient. And I'm going to now show what's the right way to approach this, okay? Alright, so fresh attempt. Here's our question again. We're this time going to use the visualize process skill. Instead of looking at the whole thing at once, let's just break it down piece by piece. Just how you should solve a data sufficiency question. We'll first focus only on the question stem. Okay, so again, what do you have? You have a region R which consists of all points x, y that satisfy this inequality. This time, I'm not going to stop here. I want to understand what this is. You know x, y stands for points in the xy plane, right? In the coordinate plane. So I have my xy plane. Let me draw that for you. Say this is my x-axis, this is my y-axis, and I am talking about all of the points that satisfy this inequality. What does it mean? Now you should know that you first need to plot the line 2x plus 3y equal to 6. And to plot a line, all you need are 2 points, right? That's all you will need. So I can see that it's 3, 0, x3, y0, and 0, 2. These two are going to work. So when I put them here, this is my 3, 0. This is 0, 2. Then the line that we are talking about, let me draw it properly. There you go. This is your line. Now, I don't just want it to be equal to 6, remember. What do I want? I want 2x plus 3y to be less than equal to 6. Now, from your knowledge of inequalities, this is going to be all of the region that is below this line. So, this is what region R is, the whole of this yellow shaded part. Now, the question is the point R, S in this region? Now I can see what the question is talking about. There is a region defined, and my question is to see whether this point R, S, whether this lies in the yellow region or not. Right now, because I don't have the statements, I have no idea, right? It can lie in the region, it can lie outside the region also. So right now I have no information, and now I'm very clear what is it that I want to see and get from the statements. Just compare this with the algebraic version. There, what did you have? All you had were two inequalities. One inequality was given with this less than equal to 6. All it had was the x and y, and the other inequality is what you had to find. There was nothing you could see. There was nothing you could relate with it. But now you know that there's a region we're talking about, and we just want to see whether this point is in the region or not, right? Now let's look at statement 1. Before we move on, tell me, how are you enjoying the video so far? If you're enjoying it, hit the like button and subscribe to the channel, because we keep coming up with a lot of this good quality content. You don't want to miss this. For now, let's continue. Alright, so what does statement 1 say? Statement 1 tells us that 3r plus 2s is equal to 6. Now, when I'm doing my statement analysis, I need whatever my question stem gave me, right? So let me quickly bring that here. Here we go. Now it's time to understand statement 1. What is this telling me? Again, try to visualize this. What is this thing? This is a linear equation in two variables. If you plot it, you know it's going to be a straight line, right? So this straight line, if I want to plot, what do I need? I again need 2 points, just like we plotted the previous line. So 2 points on this would be 2, 0, r is 2 and s is 0, and 0, 3, right? So if I plot this here again, it's going to be on the line, all r, s are going to be on the line that joins 2, 0 and 0, 3. Let me draw the line. There you go. Now you know that your point r, s lies on the red line that I've drawn. Yes, but what was the question? The question was whether this point r, s is in region R, which is the yellow region. So is it always in region R, or it can be outside? I don't have to think about any coordinates this time. I can see it here. I can see that yes, there are some points on the red line which will lie in the yellow region, so I can get a yes. But there are some points on the red line which are not in the yellow region. That means without worrying about which coordinates are these going to be out of the infinite possible that there are, I can see some of it is in the region, some of it is not. So it was so easy now to reject statement 1 as insufficient. Again, think about how this would be if you only stayed in algebra. You would be caught in trying to find which R and S work and which R and S do not work. Now, right now, because statement 1 is insufficient, I'm going to reject A and D. With this, let's move to statement 2. Okay, here is statement 2 now, and I brought what we had in the question stem. This time, about the point R, S that I need to find, I know that this R is always going to be less than equal to 3 and the S is always going to be less than equal to 2. Think about it. R is the X coordinate, right? And S is the Y coordinate. That means my X coordinate is always less than equal to 3. That means all of my points are going to be on the left of this line that I just drew. Okay, I'll clear this part so it doesn't confuse you. Similarly, for the Y, you know that S, the Y coordinate, is always less than equal to 2. Where is it 2? Here, right? And you know now my Y coordinate is always less than equal to this point. So when I look at all of this together, then this statement tells me that this R, S point that I'm trying to find out, it lies in this region. Let me highlight this in a different color. Let's see. The point will lie in this blue region. So I'll color it blue just so you can see like this. This is where R, S is. Now your question is still the same. Is the point R, S in region R, which is the yellow region? Now what do you see? Well, I can clearly see that there is this point in the blue region which is also in the yellow region. So I could easily get a yes. But then look at this point. There are going to be points in this area which are in the blue region but not in the yellow region. So I can get no also. Again, rejecting statement 2 got super straightforward because I could see everything. Just understand the power of the skill. You've already seen it demonstrated thrice on the question stem, on statement 1, on statement 2. Every time your analysis, your inferences became a lot more logical. You were not caught in any calculations. You just had to see what you had to see. Now, I am going to reject statement B also because 2 is also insufficient. So what's your next step? You combine your statements now. Alright, so now this is where I've combined the statements. This may look crazy, but it's nothing. So black line was the original line that you had, 2x plus 3y equal to 6. Yellow region is what we were given in the question. Then we wanted to just find that R, S, is it in region R, the yellow region, or not? Then from statement 1, we found out that all of the points R, S, they lie on this red line that you see. This is 3R plus 2S equal to 6. All points lie on the red line. We saw this is not enough to tell whether it's in the yellow region or not. Then the second statement told us more about R and S. It told us that R, S is going to be in this blue region that you see, defined by these two lines, horizontal and vertical. So R, S is in the blue region. So now I have two pieces of information. Now that I know both these things about R, S, that it is on the red line as well as in the blue region, that total tells me that my R, S is going to be here. Just see how I've shaded it in green. I hope you can see this. Let me make this slightly darker. So now you see in this pink color, all of the points R, S that satisfy both your statements, that are on the red line and that are in the blue region. Now all of these points, are they in the yellow region? No, they're not in the yellow region even now every time. Let me zoom it in so that you can see. Look at these points here on top. This is still not in the yellow region. But yes, everything else, any point that you take from here, you have a yes. So even now you can't tell whether this point R, S lies in the yellow region or not. Now just think how complicated this would be if you had to find your coordinates. I can't stress enough on how simple all of this visualization approach makes this question. So this makes E the correct answer, and only 22% 92% people, as I said, made the cut till here. You know why, and now you know how to get till here, right? So let me give you your takeaways now. Well, the big takeaway is that sometimes very hard GMAT geometry questions can turn into really straightforward questions if only you visualize. What is visualization? It is just seeing what is happening. So it's not just about solving, it's about seeing. And when you observe things, when you can see them, you can make stronger and smarter inferences in a lot less time. As you read a question, keep inferring and then keep putting all of that in a figure. See how when I was reading my question, I was reading my statements, I constantly kept improving the XY plane that I had, the figure that I had. I kept putting more information on it, and so that I know I have everything in place, and now I need to just see what I want to find. I wanted to see R comma S is in the region or not, right? Once I had everything in place, I just had to find one point that was not. So you keep visualizing as you go. Don't collect it. Don't let it overwhelm you ever. Finally, this is where you put yourself to test. It's a practice question. This is an official question where again you will see that the power of visualization will make this question very, very easy. If you use it the right way, you will not be stuck on this one. So I want you to put your answers in the comment section. What are you doing? You are writing the answer first, whatever choice is it. Then you're writing question stem analysis. Then you're writing statement 1 analysis, statement 2. Nothing detailed, just 1 or 2 sentences so that I can confirm your understanding. Okay, I'm going to read every single comment and I will respond wherever I see problems. Stay tuned for more such videos. If you enjoyed this one, hit the like button and subscribe to have more such content. Happy learning.